In this question, a sequence is such that the n plus 1 term is equal to the nth term plus 1.5. Part A, given that the 50th term is equal to 99 of the first term, show that the first term is equal to 0.75. Let me just write down the information first. So we have a U50 equal to 99 U1. We are also given this recurrence relation UN plus 1 is equal to UN plus 1.5. This question actually is trying to convey to us an information, but not in a direct way. They are just trying to say that this particular sequence, in fact, is an AP sequence. Why? Because if I were to shift this term over to the left-hand side, we have a UN plus 1 minus UN equal to 1.5. So this expression means that if I'm taking the n plus 1 term minus its preceding term, it always gives us a constant value, 1.5. In fact, this is how we are going to show that it is an AP sequence, by using a general term somewhere along the sequence to subtract by its preceding term. Any general term by subtracting by its preceding term always gives us a constant, means that it will be a AP sequence. And this 1.5, it means that it is the common difference. So using this expression, I can say that UN will be equal to A plus n minus 1D. This is the general term for AP. And this A will represent the first term, and my D will represent the common difference. I can rewrite this expression into this general form by using this A plus n minus 1D. I will get A plus 49D, and this will be 99A. U1 will just be my first term. I'm going to simplify this expression. I will get 98A equal to 49D. And since we already showed that 1.5 is the common difference, I can sub in this 1.5 into my D. And solving for A, I will get a value of 0.75. And this will be the first term that I need to show. Right, so shown. Let's look at part B. Part B says that find the least value of n such that U2 plus U4 plus U6 all the way until U2n is more than 2025. 2 U4, U6 plus all the way until U2n must be more than 2025. Right? Basically, what this expression is, right, we are actually trying to extract out all the even terms for this particular AP sequence. Let's take a look for this AP sequence first. We have like a U1, U2, U3, U4, U5, U6, right? And if we were to extract out all the even terms, I'm extracting out this term here, this term here, this term here. Since this is an AP, this U2 actually I can rewrite as A plus D. U4 is equal to A plus 3D, and U6 is A plus 5D. In fact, I can see that these even terms, right, will form for us another AP sequence. And for this new AP sequence, this first term will become the A plus D will be the first term of this new sequence. And the common difference now we can see is like a plus 2D already. So in fact, for this particular expression, I can still make use of the AP formula, because this is just like finding the sum of AP. And in this scenario here, 2, 4, 6 all the way until 2n is comprising of total of n terms. So I'm going to make use of this formula as n equal to n over 2, 2a plus n minus 1d. So in this scenario, the number of terms is n over 2, 2a. So now I know that my new first term of this particular sequence, right, will be equal to a plus d. So I'm going to start in a plus d here and plus n minus 1d. This time round, my d is equal to 2d and greater than 2025. We have already the values for our first term and the value for our common difference. So I'm going to start in the values. So a will be equal to 0.75 plus 1.5 plus n minus 1, and this d is equal to 1.5 greater than 2025. All right, solving this expression, and I will end up with n over 2 bracket 1.5 plus 3n greater than 2025. And we are supposed to solve this particular expression, and this is a quadratic equation. We can either solve it algebraically, but an alternative which I prefer is to make use of a GC. And since the unknown I'm solving for here is an integer value, so I'm going to make use of the GC together with the table to search for our answer. Let's go to our GC. We have already keyed in the expression here, just replacing the n with x. And after this, I'm going to go to second graph to trigger the table. All right, and our objective is to search for the value of n that give me more than 2025. So we can see that as we scroll along, you can see that the value of this expression will increases. This represents the n value, this represents the value it compute for you by subbing in the value of n. Right, so I'm going to keep scrolling down. If it takes too long, I'm going to press second window. Maybe I'll just start from 35 instead. Second graph. Okay, it seems like get closer already. Okay, then we can see that when n is equal to 37, it gives us 2081.3, which exceeds the 2025. So I know that my answer is actually n equal to 37. But for presentation purposes, we're going to draw a table like this. This will be the n. This will be the expression n over 2, 1.5 plus 3n. So we're going to write down the value that the one before that, the one that I want, and the one after it that I want. So this is the one that I want. So I'm going to write down 36, the one before it, and the one after it. So for 36, I will get a 1971. 37 is 2081.3. 38 is 2194.5. 37 is the value that I want. So therefore, I can conclude from GC, this n will be equal to 37. In part C of this question is given that U25, UK, and U5 are the first three terms of a geometric progression. Part 1 wants us to find the value of k. We have already shown that from our previous part that UN is a AP. So later on, perhaps we got to make use of this information. Let's keep it in mind first. Let's write down the information given by the question. Since U25, UK, and U5 are the first three terms of a GP, I'm going to write down GP. The first term will be the U25. Our second term will be my UK, and my third term will be my U5. Since this is a GP, I can relate them using a common ratio. That means to say that if I were to use this divided by this, I will get the common ratio R. This divided by this also get a common ratio of R. Or alternatively, we can just imagine we multiply by R to this, I'll get this. Multiply by another R to this, I will get this. So from here, we can formulate an equation saying that the UK divided by U25 is the same as U5 divided by UK. And I'm going to cross multiply, I'll get a UK square equal to U25 times U5. And since we already shown that previously UN is a AP, so we're going to make use of the general term for the AP formula. This, I'm going to use the A plus K minus 1D and the whole thing square. Similarly, this one, I'm going to make use of the A plus 25 minus 1D, and this is A plus 5 minus 1D. And from the previous part, we already found out that the first term is equal to 0.75 and the common difference is 1.5. Subbing in into this expression, this is equal to 0.75 plus K minus 1. This is equal to 1.5. The entire expression square. Same thing here. This is 0.75 plus 24 times 1.5. This is 0.75 plus 4 times 1.5. And using our calculator to evaluate this expression, I'll be able to get 0.75 plus K minus 1 times 1.5. Pressing this whole expression into calculator and square rooting it, I'll get a value of 15.75. And solving for K, the answer is equal to 11. Right, now we're going to look at our part 2. Find the sum of the first 13 terms of the GP, giving your answer to 3 decimal place. So now we are going to find the sum of the 13 terms of this particular sequence. All right, first I'm going to write down the general formula for finding the sum of n terms of a GP. It's given to be A, this is the first term, minus 1 minus r to the power n over 1 minus r. So we require to find out what is the first term of this GP, and which is happen to be U25. So U25 will be equal to, we have the value already, which is equal to here, this part here. Let me just rewrite it. So you just be the A plus 24D. This A is equal to 0.75 plus 24 times 1.5. And this will give us a value of equal to 36.75. And as for the common ratio of this particular expression, it can be computed by using this value here or this value here. I'm going to go for this. So the common ratio is equal to U5 divided by UK. We already found K is equal to 11, so I'm going to replace the K with 11. And this on its own, it is a AP. So I'm going to use the A plus 4D. So in this case, A is equal to 0.75 plus 4 times 1.5. Same thing for the denominator, 0.75 plus 10, 1.5. Evaluating this, it will give me an answer of 3 over 7. So this is the first term, this is the common ratio. I'm going to put this value into this expression here. Therefore, I'm going to S13 is equal to, first term is equal to 36.75. And 1 minus 3 over 7 to the power of 13 over 1 minus 3 over 7. And pressing this into the calculator is 64.311. So therefore, this will be the final answer required for C part 2 of this question.